The biggest question I always get is, how do I know that I need u substitution? Okay, if you look at the problem and you can't just say the answer, you can't just go backwards and be like, hey, what's a function that if I did the derivative, I would get this as my answer? We're going to go ahead and close the computers. If you can't just say the answer, like for example, and like you just did on your quiz, what would be your antiderivative for that? Yeah, you'd have one. You see how you could just say it? Okay, if you can't just say the answer, it's a more complicated problem. We're going to go ahead and close the computers now. And you're going to need a u substitution. So that's how you know you need u substitution. That's the first step. Second step is, what do you let u equal? You want it to be either the thing with the highest power or the guts of the problem, like the stuff inside the parentheses or inside the square root, like the stuff that's inside, or when in doubt, you want to let it be the denominator. Here's the thing though, if you guess wrong and you pick the wrong thing for you, the problem simply will not work. And you'll go, oh, I'll pick something else. So if you're not a giver upper, like I one year had somebody say, so Ms. Cole, if I just keep on trying, I'll eventually get it. Yeah, you almost can't mess it up if you just keep on trying. Now, if you're a giver upper, that's a different story, all right? What do you think we should let u equal for this? I'm writing with pen, so I'm going to kind of guide you towards it. Yeah, the inside stuff, right? 4x cubed minus 3. This is like a margin problem. Just off to the side, we're going to write u equals all that stuff. Then we're going to do the derivative. Now, I'm only going to write out this step once. After this, I want us to skip this step. Do you know how we write dy dx, derivative of y with respect to x? Or do you remember dv dt? It was volume with respect to time. All right, this is going to be du dx, derivative of u with respect to x. So what is that derivative? 12x squared. We're going to multiply the dx to the other side. So it should look like this. So you just slide the dx to the other side. From now on, I'm going to skip this step and jump straight to here and just move the dx over so that we're not just doing a whole bunch of recopying. Now, here's where you'll know if you did it right or not. That needs to show up in the problem somewhere. Now, you can adjust a coefficient, which we're going to need to do here. You can't adjust a variable. There has to be an x squared in the problem. It has to match exactly. Like it's either going to work or it's an undoable problem, right? Do you see an x squared in the problem? Huzzah! Okay. Do you see a 12 in the problem? No. How would we divide out a 12? 1 over 12. All right, so we're going to say 1/12 du equals just x squared dx. Or you could think of it like dividing the 12 to the other side of that equation, whatever suits you. Now, I had always in years past taught this with a highlighter. I would highlight the parts we were substituting, but then I found out you're not allowed a highlighter on the AP exam. And I'm kind of like, well, I don't want to teach it in a way that you're not going to be able to do it on there. So now I just underline, okay? Or if you don't want to underline, if you're like, I can see it, Ms. Cole, then that's fine. You do you, all right? So we're going to replace the x squared and we're going to replace the dx. It's a substitution. We're replacing those two parts with 1/12 du. We're going to remove those and replace it with 1/12 du. The 1/12 is going to go out front of the integral. The du is going to go at the end. Whatever you didn't underline is still there. So whatever you didn't substitute out is still there. So what part is still there? 4x cubed minus 3 cubed. Now, what did we say 4x cubed minus 3 equaled? U. So it's u cubed. At no point should you look down and have a mixture of x's and u's. If you do, you have done goofed if that happens, all right? These should all be u's. You should have a u and a du. If you have an x and a du, that's a problem. Go back and figure out what happened. Now, here's the most common mistake I get with this. It feels like you already did a lot of work, doesn't it? People feel like the problem's over. Don't forget to do the antiderivative. You have to actually integrate. Okay, that's what this symbol in the du is telling us to do. I'm going to just hold on to the 1/12 for a second. What's your antiderivative for u cubed? And actually, that's kind of like the one I made up here. Yeah, 1/4 u to the 4th or u to the 4th over 4, whatever you want to say, and then plus c. And now we're just going to kind of clean it up a little bit. 1/12 times 1/4 be 1/48. Now, in place of u, because it says u to the 4th, what was u that we said? Yeah, that 4x cubed minus 3, and then plus c. Now, I grabbed this worksheet I didn't make this, or we may not do every single problem on here, but it's a matching thing. So if you flip to the back, you should be able to find that answer. So do you see that one somewhere? Because this is, you can kind of check your own work. If I don't do all of them, you could do the rest for practice and find your answers. Do we have something with a 48th in there? D as in dingo. All right, let's try another one. Did they not put a plus C? Oh, they did. Okay, I was going to say blasphemy and sacrilege. All right, number 2. What do we want to let u equal? 4x minus 3. And again, if you're like, I can't figure out what to let u equal, pick something and go with it. If it doesn't work, try something else. If you're not a giver-upper, you will eventually figure it out, all right? So that derivative, du is going to equal, what's your derivative of that? Just literally 4, and that, perfect, thank you. Slide the dx over. Now here you have a choice. You can either do what we did on this one, like how we multiplied by a 1/12. You could multiply by a 1/4, cancel it out entirely. Or if you want to go fancy, do you see how there's a 2 in the problem? How could you turn a 4 into a 2? 1/2. So you could do 1/2 du equals 2 dx. Or you could do the 1/4. 2 times a 4th is going to be a half. You'll end up at the same place at the end. It's kind of up to you. So if you want to underline, we're replacing the 2 and we're replacing the dx. So I'm underlining those. Again, I wish we could use a highlighter. I used to have everybody highlight it. In place of what I underlined, we're going to put 1/2 du. So 1/2 goes in the front, du goes at the end. Whatever I didn't underline is still there. So what is still there? U to the 3rd. Good job. And again, this is the most common mistake, is people feel like they're done. And justifiably, you feel like you did a lot already, or like the problem's over. You have to actually integrate. If you still see an integral symbol, you have to do that. So it would be 1/4 u to the 4th plus c. And then you just have that one step of like kind of cleanup. It would be 1/8. And then I'm going to put back in what we let u equal in the first place, which was what? 4x minus 3. And if you want to flip over and find your answer, which I heard some of you flipping your paper over already. Some people are super speedy. Do we have a letter for that? I don't want to flip before everybody's got it. What is it? G as in gorgeous. Yes. It doesn't disappear. We did an antiderivative. That's the symbol. The integral symbol and the du are what's telling us to do an antiderivative. This is the analogy I always use. Give me a perfect square. Somebody give me a perfect square. Let's do 81 because it's a little bit bigger, right? What's your square root of 81? 9. The symbol didn't disappear. We just did that step. Are you looking at this step right here? Yeah. So we're the one above that? So I multiplied both sides of this equation by a half. A half of 4 gave me 2. And then, can I highlight real quick? Hold on a second. It's better with a highlighter. So we are replacing the 2 right here and the dx with 1/2 du. So I'm removing the part I highlighted and substituting in the 1/2 du. And then what's still there was the u cubed. That gets us to this step. 1/2 is kind of just there. I just left it. It's sort of just a coefficient. And then we did our antiderivative, which was 1/4 u to the 4th plus c. The du didn't disappear. We just did that step. Du is replacing dx. It serves the same purpose. Okay, cool. Let's do number 4. 3 and 4 are similar. They're both trig. Okay. What do we want to let u equal for this one? Now, let's talk our way through that. If you let u equal 4x minus 3, what's the derivative going to be? Just 4. And you would end up with sine u cosine u. Can you come up with a function that has sine cosine as its derivative? So you're going to need to let u equal a little bit more than that because it won't work. Perfect. It's going to be sine 4x minus 3. In this one, I think it will work the other way, right? Because you'll just end up with, here, you know what? Let's do this problem this way and we'll go back and do it the other way and we'll see if it works both ways. In theory, it should. I feel like that you'll just have a negative and then the negatives will cancel. I think it should work. But I would go with sine because what's your derivative of sine? Cosine, leave a little gap here. It's going to be cosine of all that stuff, dx. Sorry, I ran into the edge of the paper. And the reason I left a gap there is because what's going to have to go out front? Why would there be a 4? There's a chain rule. You have to chain on the derivative of 4x minus 3, which is 4. Okay. Now, do you see how there's a cosine of that stuff in the problem? Cool. It matches. But there's not a 4. So what are we going to need to adjust with? A 1/4. Perfect. 1/4 du equals all of that dx. And I'll highlight. You're not allowed a highlighter on the AP exam. I'm not really sure why. I don't know what kind of shenanigans you're going to get up to with a highlighter, but you're not allowed to have one. I don't understand the point of that, but here's some ideas. Okay. So in place of, and just watch me highlight it, in place of cosine 4x minus 3 and dx, in place of all that, I'm going to put 1/4 du. And whatever I didn't highlight is still there. Which is what? What's still there? You. Don't forget to actually do an antiderivative. Can I finish this thought real quick and I'll take that question? And I keep harping on about that because I've been doing this for over a decade. It's like this step that everybody skips. They just want to go straight past this and write plus C and be done. I get it. You already did a lot of work, but you're not done yet. All right. That 1/4 is kind of just there. What's your antiderivative of just plain U? Yeah, 1/2 u squared plus c, and then you just have to kind of simplify this down a bit. It would be 1/8. Yeah, now where does the squared go when you have sine of, good, it's sine squared of the stuff plus c. I'm going to take this question, but you can flip over and find what letter it is, and then I'll come up with something silly that it stands for. Go ahead.
So why did we just take the 1/4 and separate it from the
You can take a coefficient and put it in front of the integral. You cannot take a variable and take it outside of the integral. So as long as it's just a number, you can do that. Do not ever take an x or a u outside of the integral. It does not, because it's constant. Or, well, you're just scaling it by that factor. It doesn't matter. Hold on. What letter did this end up being? C is in cantaloupe, okay? It doesn't matter if you, let me see if I, you know what, we're not going to do number 3. Just don't write this. I'll put, if you want to do number 3, you can. Let's do 8. X, D. Okay, let's do this just real quick so you can see how it works, all right? Your antiderivative would be 4x squared plus c. Do we all see that? Okay. Or I can take the 8 out and make it just x dx. The 8 is kind of just there. What's your antiderivative of just x? So it doesn't matter where you multiply the 8. It kind of boils down to personal preference. It's really up to you how your brain likes it best. I'm obviously going to teach you everything how my brain likes it best, but you're allowed to be different and still get the same answer. We're allowed to be different, okay? This has nothing to do with problem 3. I was just answering his question. Nothing at all. We're going to skip problem 3. I just had some space there, and so I used it. That has nothing at all to do with problem 3. All right. Let's do problem 6. Let's do problem 6. What would you want to try to let u equal for that one? Not the whole thing, but close. So the 4x squared minus 3, the guts of it, like the inside stuff. No. Hold on. Shh. We're getting all scattered because some of you are asking really great questions and some of you aren't listening to me answer those questions. And then we're splintering here, okay? What is your derivative of square root? I cautioned you on just memorizing it. Derivative of square 1/2 square root. Is there another square root in the problem that we could make that match? No. So it's not going to work. But I promise you, if you try it, you will get to a dead end. Like these problems simply won't work if you do them wrong. And you'll go, oh, whoops, I better pick something else. Okay. So what is your derivative of that? 8x dx. Good job. So let me show you how this one would work. If you didn't worry about this 2, and in fact, that's not a 2, it's actually a 1/2. Okay, but say you didn't want to worry about that. I'll do this one differently. You can kind of decide what your personal preference is. Say I see this 8 and I'm like, I'm going to just get rid of it. I'm going to multiply by a 1/8. If you want to do it differently, we will end up with the same answer. We are allowed to be different. It's okay. All right. So in place of x dx, I am going to replace it with 1/8 du. Now that 1/2 can also come outside of the integral. So it would end up looking like this. I took that 1/2 and brought it outside, and I took my 1/8 adjustment and I brought it outside. Now what's still there is the question. It's a square root of u. Okay, so 2 questions. Where is the square root? It's on the denominator. And what is your exponent for a square root? Good. It's going to be 1/2, but it will be negative. So it's u to the power -1/2. I get that that's scary. It's negative and a fraction. It's like double whammy. Okay. But it's negative because it's in the denominator, and it's a half because it's a square. Perfect. Okay. Good job. We're going to add 1 to the power. So -1/2 plus 1 is, oh, cool. It's not negative anymore. Sweet. And then in front of that, you would put the reciprocal, which is 2. And I'm going slow so that everybody can kind of stay with me. Now, what else do I have there? My baggage that I sort of need to bring along with me. 1/16, beautiful. And then at the end, plus c. So this would really be 2/16, which would be 1/8. Good job. And then it's u to the 1/2, which means square root. It's not negative anymore, which is cool. Yay, huzzah. All right, and then what goes underneath of it? 4x squared minus 3 plus c. All right, let's go see if we can find the correct letter. Yeah, go.
If you leave it as 2/16 times 4x squared minus 3
to the power 1/2. Free response, perfectly fine. But if it's multiple choice, it's not going to look that way. It's going to look like this, and you're going to have to be able to reconcile which one is your answer. Did you guys find it? Which one is it? H, as in hot potato. Okay. All right, we'll do a couple more. No, we want to keep things positive. Let's do, which one of those? Let's do 7. We'll do 7 and 9. We'll do the odd ones back here, right? So number 7. What do you want to let u equal? 4x squared minus 3. Again, hey, Miss Cole, I'm nervous I'm going to pick wrong. Don't be. If it doesn't work, you pick wrong, just try again. Just try again. As long as you don't give up, it's going to be fine. All right, the derivative of that is 8x dx. Now, instead of doing a 1/8, but you could do that, let's try and turn the 8 into a 2. Do you see how there's a 2 in the, that's your other option. You could do that instead. What would you multiply by to turn an 8 into a 2? A 4th, good. So again, it's up to you. It boils down to personal preference, and we are allowed to be different. I don't want to hear anyone say that's the wrong way. It's not. It's up to you. Okay. All right. So in place of the 2x and the dx, I'm going to put 1/4 du. Now, what you didn't highlight or underline, not allowed to highlight. So what you didn't underline, what you didn't substitute for already is still there. So what is still there? U squared, but where is it? So it is actually u to the -2. Negatives can be scary, but you just got through a -1/2, so you can certainly do a -2. All right, you're going to add 1 to the power. It's going to become less negative. -1, good job. In front, you would need to put a -1. Or did I hear you say divide by -1? You could do that too. That's fine. I like to just throw the negative out front of the whole thing. That's my personal preference. But am I wrong? Am my way wrong and your way is right? No, it's fine. We're allowed to be different. So this is going to be negative a fourth. And where does u go in this case? Good, because it's a negative power. And what was u? I forgot. Was it? Yeah, that's why it's important to write it over here, because at that point I get a little ADD. All right. And so it will look like that. All right, which one is that? A, as in abracadabra. Yes, go ahead. Oh, you're good. Okay. All right. So now we're going to do one with boundaries. And actually, I'm probably going to make up another one with boundaries so that you can see how this works, because we're probably going to need more than one example on this. Do you see how there are boundaries on this? It is definite, not indefinite. We will not put what? Good. You will put a such that bar. You will do upper minus lower, and you will get an actual numeric answer. What does the numeric answer represent? Area under the derivative means slope, integral means area. That's calculus in a nutshell. Those are the two branches of calculus. Derivative is slope, integral is area. Okay, what do we want to let u equal? X cubed plus 4. The thing with the highest power, or when in doubt, pick the denominator. Okay, derivative of that, 3x squared dx. Good, that was quick. All right, now you can either do a 1/3, or you can look at the problem and go, oh, there's a 6 there. How would we turn a 3 into a 6? Multiply by 2. So 2 du equals 6x squared dx. So in place of, and if you're working ahead of me, because some of you, I know, like you get into a groove with these, you start turning them out. Can you hold on a second? Because I need to explain to you what to do with the boundaries. All right. Leave it blank for just a second. In front, you're going to put a 2. At the end, you're going to put a du. What is still there? But where is it? Good. So it's 1 over u. Good. Okay. Now the boundaries. You have to change them. These are x values. Now it is u. We have to turn the x values into u values. It is very easy. In fact, it's so easy that it's very easy to forget to do it. All you have to do is take your 0 and your 3 and plug it in right here and see what you get. So let's do 0 first. 0 cubed. Oh, you just jumped straight. I was going to walk you through it. 0 cubed is 0 plus 4 is 4. So there's 4. And then if you plug in 3, 3 cubed, 27 plus 4, 31. Hey, Miss Cole, what if I don't want to? Tough. You have to. You have to. All right. Now your feelings are valid, but you still have to do it. All right. What's your antiderivative for 1 over u? Yeah. ln, and it is going to be absolute value. Oh, I forgot the 2. Copy error. Now here's the cool thing about changing the boundaries. You do not have to plug back in this x cubed plus 4. You get to skip that step. Go ahead. Then it's just whatever you get. Well, when you add 1, you would get u to the 0, and you would hopefully go, oh, whoops. Do you get what I'm saying? Yeah. Like my hope is when you got u to the 0, you would go, oh, dang, something is wrong here. Okay. So we're going to do upper minus lower. So it's going to be 2 ln 31. I don't need the absolute. Can you stop that? I don't need the absolute value anymore, because what is the absolute value of 31? 31. Okay, once you get down to a value, you don't have to write it anymore. And then it would be minus 2 ln 4, whatever that is. But that is a numeric answer that represents an area. Let me make up another one just right quick, just to make sure we understand how to change the boundaries. Let's put an x right here, and let's do another square root. Give me like a single digit number. Sorry, said single digit. We'll do that. There we go. Oh, and I need boundaries. Do you see how easy it is to make up a problem? Just throw some numbers in there. Okay. What would we let u equal? 2x minus 9. Your derivative is 2dx. Oops, I messed up.
What happened if you made u equals square root? Would that make a difference?
Yes, because your derivative of square root is 1 over 2 square root, and there's not another square root in the you would hopefully go, oh, whoops. It would get super complicated, and it wouldn't work. All right. So what am I going to do to adjust for this? 1/2 du equals dx. So the only thing I get to substitute in this case is dx. Out front, I'm going to put a 1/2. At the end, I'm going to put a du. What's still there? And you would write it as u to the power 1/2, but here, let me write it as square root of u because I'll explain something else to you. And then your boundaries, you're going to take them and plug them in right here. So what is 4 going to give you? 2 times 4 is 8. So -1. And then if you plug in 6, what is that, 3? On the AP exam, they'll give you multiple choice where they will say, doing a u substitution will give you which one of these options. And then this is your answer. You don't have to go any further. They'll make that be the answer choice. And if you don't change the boundaries, it'll be wrong. Yeah, but I had to get rid of that. I messed up. I threw an extra variable in there, and it was going to be an undoable problem, so I whited it out. It wasn't going to work with the x in there. I had to get rid of it.
I assume if you do it with like a different value, it would still give you the same boundary.
If you do what?
Because like you said, you can still like keep guessing and checking. How would you know if you were right or wrong?
So I will answer that as long as you guys all stay focused. Can you stay focused for me? So like, for example, this one, because I got the question over here. What if you let u equal the entire square root? All right, well, your derivative is 1 over 2 square root. And then you'd have to chain on the derivative of that, which would be 2. I mean, is any of this in the problem? There's no place for you to substitute it. It won't work. Like, where was another one that we were like, hey, what if you did something else? Well, that one might actually work both ways because there will be a negative. I think that I'm going to actually work that out and see if it works. But anyway, if you choose the wrong thing, it simply will not work. You'll go, oh, this is not over there.